Hello, everyone. Video number dos today, numero deux. It is March 14th, 2024, and I took the dogs out for a nice run hike. It was good. Did some meditation, and then I got into the nerd stuff. I don't usually like getting too much of the nerd stuff because it's so much. I've gone through a lot of like mathematics. Algorithms and calculations and stuff like that in the last couple of weeks in astronomical mathematics and talking about latitude and longitudes and distances and all of this friggin' stuff. And that's like it's mind friggin' blowing stuff. And so I wanted to have a little bit of a friggin' break, but again, like just people like Craig exist. And I'm looking at his site and his wife's website, and it's not credible at all. So if you actually look at what they try to cite as debunking anything flat Earth related. If you actually look at what they're linking and stuff like that and go through it, it's ridiculous. It's ridiculous. And a lot of the stuff too, it's like from the 1950s and 60s and nothing current. And so they think that they're just banking on people just being too lazy to look at what they're sharing. And so people should take a look at the websites and see what they're sharing and just make fun of it. You know, I call it out for what it is because it's ridiculous. And so anyways, I'm going to share a really good video. So many I can discuss. This is from the Plain Truth Network. I shared a bit of his content earlier. Like, you know what? I'm actually going to share.
But there's some topics I'd like.
Because what I was saying before is like at least when he was doing these videos, this was over 4 years ago, I think maybe. Wait 1 minute here. Maybe I'm wrong. 6 years ago. Over 6 years ago. And so he's really good with like he's not bias, right? And so he looks at things from a scientific perspective, not like Craig, you know, who I'm going to keep on friggin' hating on because, again, he's been nothing but insulting to people from the flat earth community for years now. And he has zero credibility or anything to substantiate his claims. And so this is very interesting. And so, Craig, hopefully at some point you'll actually stop getting paid or funded by propagandists because you're destroying humanity. You're getting entertainment out of it. I can see it, and it's just ridiculous that people get enjoyment out of lying to humanity, knowing or should be like knowing that children possibly are going to be watching these videos and others, and so just like deceiving, you know, parents, children, and stuff like that as well. So it's really frustrating. And Brian Mullen. Check out his work. He has incredible work and just goes through the math. And so, Craig, this is over 6 years old. I challenge you to also do a debate with Eric Dubay or Brian Mullen or countless others. You won't though, and even if you did, all you're going to do is insult them. And so
to the gravitational constant. Before I begin, I really want to thank everybody who commented on the first episode. The positive feedback was fantastic. I had no idea the video would be so well received. Thank you all for taking the time to watch it and really think about it. And even in some of the negative comments, there were some very good questions asked. And I would definitely like to revisit the plane problem after a few episodes. But there's some topics I'd like to cover first because I think it'll better explain the plane problem as we go along. And so the other thing I want to say is that I'm not claiming to be right about all this.
Apparently he's This is many years ago, and I understand that if you want to just go and forget about YouTube and go on like into your engineering career, but I guess like I was just told that he's focusing more on his engineering degree and he stopped with the videos.
When I first discovered flat Earth theory,
he doesn't need to do any more videos. Look at this.
But the problem was I couldn't. I realized that there were some very good points being brought up by the flat Earth community.
Rewind it.
Thank you all for taking the time to watch it and really think about it. And even in some of the negative comments, there were some very good questions asked. And I would definitely like to revisit the plane problem after a few episodes. But there's some topics I'd like to cover first because I think it'll better explain the plane problem as we go along. And so the thing I want to say is that I'm not claiming to be right about all this. When I first discovered flat Earth theory, I thought I could debunk it right away. But the problem was I couldn't. I realized that there were some very good points being brought up by the flat Earth community. And that's why I started this series, because I'm really asking for help here. I can't explain these things. And, I've got a pretty strong physics background. I took 2 physics courses in high school and then a bunch in college to get my degree. And maybe I'm missing something, maybe I'm not. But one of my favorite sayings in the engineering world is you learn 10 times more from your mistakes than you do from your success.
Yep.
This is what we always tell rookie engineers. This is what they told me. Don't worry about making mistakes. Don't worry about being wrong. Because you are wrong or you do make a mistake, you want to find out why. And on the way to finding out why, you learn a ton. So never be afraid to be wrong, because you can learn from it. And no one on this earth who has ever lived on this earth has ever been right all the time. All the time. It's never going to happen, and it's never happened. So accept it. Learn from it. So anyway, this episode is mainly about gravity, but it's about the gravitational constant in the gravity equation. However, to get there, we need to start with some basic physics. So I've set up a problem here with the Earth, represented by this blue ball, and me or any other man.
And a correction there, that's not a blue ball. That is a circle. It's 2-dimensional, not even. And so, and if you look, from the top down, this could be a cone with a circular base. This could be a circle. This could be a plate. This could be a sphere. This could be a globe. This could be a ball looking downward. And the calculations for the distances and stuff like that that I've discussed and shared and proved repeatedly, and people are trying to allow astronomical measurements and stuff like that. No, it's the exact same. There's exact same calculations. And I'll show you with ChatGPT again, because what Craig doesn't do is give good science or any science. And he doesn't understand things, which is important. The distance between locations on Earth are the same, whether a globe, sphere, or circle. You are correct. So again, this is just to reiterate, and countless conversations with ChatGPT where I completely destroyed ChatGPT. So Craig, you really think that you are going to friggin' stand on any legs? All you're going to do is insult me the entire time, and I don't care. And then you're just going to show your cards. All you do is insult people.
Or woman standing on the Earth, and how we determine the weight of that person, okay? Or the force of gravity acting on that person. Weight and the force of gravity are actually the same, or at least that's the accepted belief in physics. Weight is actually caused by the force of gravity of the Earth pulling down on the object, in this case, the person. And so the bread and butter physics equation up here, one of the first equations you learn in Physics 1 is force is equal to mass times acceleration. This is what Newton based all of his 3 laws of motion on. And since his boy Copernicus, 150 years prior, had come up with the solar system, he knew that he needed to come up with an equation that would not only work on Earth, but would work throughout the universe. Okay? And so what this equation says is that the force acting on an object is equal to the mass of that object multiplied by the acceleration that the object is experiencing. Okay? And mass is defined as the amount of matter in an object. And in Physics 1, they hammer into your head that mass is the same throughout the universe. Only weight changes because the gravity on each planet can change. The gravity on the moon is less than it is on Earth. It's supposed to be about 1/6 of what it is on Earth. And so I was taking physics, and I had just taken chemistry, or I was taking it at the same time. I can't remember. But I immediately thought about the fact in the lab, we were weighing things in terms of grams. And in the metric system, grams and kilograms are actually units of mass. But to determine mass, we actually weigh it, or weigh an object, and we say this is how massive it is. So I thought to myself, well, if that's the case, if I took that same scale up to the moon, it would definitely give me a different reading because the force of gravity is less, and that's what's pulling the scale down, right? So how can that be? How can mass be the same throughout the universe? Does that mean we would have to calibrate our scales to work on the moon so that they show the same mass that we get on the Earth? Or do we use a conversion factor instead? Or how does that work? Does that mean that just all mass in the universe is actually defined on Earth? I don't know. I never really got that. But at the time, I had been in school for a long time. I was 18 years old, and I was ready to get out and go make some money, so I didn't really ask too many questions. However, I always questioned that, and I always thought about it, and I've talked about this with some other people, and there are a lot of people that say, yeah, it doesn't really make a whole lot of sense, but it's accepted in the physics world. So anyway, that's mass. Okay? The mass of an object, the amount of matter in an object. The acceleration is defined as any change in velocity. Okay? So velocity can be measured in miles per hour, as I did show in the first problem, or kilometers per hour, kilometers per second, meters per second, whatever. That's the rate of velocity. However, acceleration is defined as any change in velocity. So in this example, if I'm standing right here on this Earth, okay, I have a velocity. I'm moving with the Earth. As you remember in the first problem, he said, I'm in Central Florida. My velocity is probably around 900 miles per hour, maybe a little less, somewhere between 850 and 900 miles per hour. Okay.
We're not spinning. I proved that in countless other videos. I'm just going to keep this going. The sun and the luminaries do travel above us. The sun travels from east to west, 15 degrees every hour through the zodiacal signs every 2 hours, 24 hours in a fucking clock, this divine clock. So yes, Craig, I'm ready for this conversation.
Okay. But since the Earth, I'm supposed to be standing on an Earth that is rotating.
I bet you didn't know that.
This direction, that velocity is constantly changing. Okay, so when I get over here, this is exaggerated, obviously, but now my velocity is pointing this way. So even though I'm standing at rest, because of this theory, I'm constantly accelerating because the direction of my velocity is constantly changing. And this will be better explained in the next episode when we talk about centrifugal force. So anyway, since weight and mass are different, weight is actually considered to be a force. This force of gravity, we have weight over here and weight here. Weight is equal to the force of gravity pulling me down. Okay, so this equation can be rewritten. F equals ma can be written as weight is equal to mass time.
Friendly reminder: he's using himself as an example because he's more dense than the environment that he's occupying, and so he has this. He has the ground below him, which is keeping him from sinking, like let's say, for example, like a penny would be thrown in the ocean, right? This has nothing to do with gravity. It's less dense than the environment that it's occupying. And yes, pressure and temperature also do matter. I'm not saying that at all. But what I'm saying is like there's no like friggin' gravitational force, that's pulling the water, to the earth and humans and stuff like that, and not impacting things like subtle winds, slight winds, and the bees and flies and things like that. And or helium balloons. Come on.
Little g here. And little g is considered the acceleration due to gravity, or the acceleration at which things fall towards Earth. Now, I post a link in the description to a trailer for the BBC series, episode 4, Human Universe, in which Professor Brian Cox from the UK, travels to the Glenn Research Center in Cleveland, Ohio, to do an experiment with NASA's vacuum chamber. And in the experiment, they drop a clump of feathers and a bowling ball. And the first time they drop it when there's air in the chamber, the bowling ball obviously falls a lot faster than the clump of feathers. But when they remove all of the air from the vacuum chamber, both the feathers and the bowling ball fall at exactly the same rate. So what this little g says is that all objects accelerate towards Earth at the same rate unless there is some type of fluid preventing them from falling at that rate. And so the more dense something is, the faster it'll fall through the air. The less dense, the slower.
Yep.
It's just like in water, something heavier or more dense, more massive.
He's giving a general idea of what it is. It's a good one. And Eric Dubé says the same thing. I also quoted his take on gravity as well.
Faster than something that's less massive or less dense. And if the density is actually less than water, it'll float. The same with our air. That's how hot air balloons work. Or blimps with helium inside them, or balloons. That's why they float, because their density is less than that of air. But when you get rid of air or any fluid, everything falls at the same rate.
Make the
really
the
great
balloon go up and travel and move and
watch it. It's very interesting to see.
Go up and down.
Okay, so that's weight. Okay. And weight or force in the metric system is measured in newtons. Okay, so one
Obviously. Newton the
obviously,
Freemason.
credit to the guy that came up with this. 1 Newton is equal to 1 kilogram times acceleration due to gravity, or rate at which things accelerate towards Earth, which is 9.81 meters a second squared. So 1 squared, the 1 Newton is equal to 9.81 kilograms times meters per second squared. Okay, remember that a Newton is really equal to units of kilograms times meters per second squared. 1 is equal to 9.81.
I'm taking notes because I don't have this memorized. I've gone through these videos before and stuff like that too, and obviously ones like this, but like I'm just going to refresh myself, make sure I have friggin' notes. Make sure I have it on paper.
So I weigh about 160 pounds, and in the English system, I could just say that's pounds mass, or actually I can say that's pounds force, but in the English system, we don't actually differentiate between with two different units between mass and weight. There is a unit called a slug that's used for mass, but nobody uses it, or that is mass, but nobody uses. So if I say my weight is 160 pounds force, I can convert that to mass in the metric system, which is about 72.6 kilograms. So my weight in the metric system would be 72.6 kilograms times 9.81 meters per second squared equals roughly 712 newtons. Okay? That's my weight in metric units. So over here, we have the equation due to gravity. Okay. And that says that the force of gravity is equal to the gravitational constant times the mass of one object, in this case, me, this is represented by a little m, times the mass of another object, which would be the Earth, divided by the distance between them squared, which in this case would be the radius of the Earth. Now you should actually add the distance to my center of mass from the Earth's surface, but it's so insignificant that it doesn't really.
And I know that we know the radius and then we know the diameter and the circumference of the friggin' Earth. And does friggin' Mr. Craig know 24,901 fucking miles, approximately 40,000 kilometers circumference, and approximately 8,000 miles fucking diameter, approximately 4,000? No, he doesn't know any of this stuff.
Okay, and the gravitational constant, which I should have written down here, is equal to 6.6.
Actually, I don't know if he does or not. I'm just hating.
7.
He should.
408 times 10 to the negative 11 meters cubed over kilograms times seconds squared. Okay? So if you plug the mass of Earth, which I have written here, was 5.9726 times 10 to the 24th kilograms, really big number. My mass, 72.6 kilograms, and the gravitational constant and the radius of Earth, which is 6,371,000 meters, you will get 712 newtons, roughly. Pretty close. Close enough to say it's the same. To say that to accept the fact that, well, the assumed fact that gravity is causing this weight, and that's why I have weight is equal to the force of gravity on here. Okay, this is what is taught in physics. That this force of gravity actually creates weight, but there's just two different ways we can calculate it. Okay, but Newton came up with this before we came up with the equation for gravity. And in fact, Newton only proposed the equation. He didn't actually finish it. He said from looking at the solar system model and watching things in the sky that he thought or he assumed were orbiting Earth based on Copernicus' work, that the force of gravity was proportional to to the mass of one object times the mass of another object divided by the distance between them squared. Okay? He said they're proportional, they're not equal. So what this means is if either one of these masses go up or both of them go up, the force of gravity also goes up. But as the distance between them increases, the force of gravity goes down. And as you can see, this is squared, so distance plays a big part here. So he eventually proposed that he needed this big.
And this is like the independent variables that we're talking about, because in science too, for experiments, like you have to identify dependent variables, independent variables, and there could be multiple independent variables, and so come on.
Here, this gravitational constant.
Dependent variables. I mean, there could be multiple dependent.
He didn't
Dependent
know
variable.
how to determine that, but he did know that the units would be what we have right here, meters cubed over kilograms times second. Now, he might not have been using the metric system then. I haven't actually looked into that, but he would have been using something similar. So I'm just going to assume that he used metric units, because if you combine the units in this proportion right here, you would get, assuming the masses are measured in kilograms, you would get kilograms squared over meters squared. And if you multiply that times this factor down here, you will end up with
Mass could be pounds, kilograms, it could be ounces, it could be grams, like
kilograms times meters a second squared, which is equal to a Newton, or a unit of force. Yeah, just like I showed in the original equation, the original bread and butter equation over here. So that said, he theorized that there was this gravitational constant, but he didn't actually figure it out before he died. And it wasn't until a little over 100 years later, 120, 130 years later, that a man named Henry Cavendish came along. Henry Cavendish was very wealthy, and he did a lot of things apparently.
Cavendish, very wealthy, also a Freemason. Again, I'm related to science. I'm aware of that. But when looking at data or content or your news, you need to look at the source also, right? It's for anyone that says otherwise is naive, because there are a lot of wolves in sheep's clothing, and there's a lot of people that are representing a symbolic, virtuous position or role in society, and they are absolutely corrupted and blackmailed, as I continuously address in all my videos with proof.
I've listened to some very respected physics teachers praise his work, and I've studied some of his work, but mostly what I was interested in was.
Oh my God! So this comes from James Mason. I was watching Nathan Oakley 80 back then, because this was several years ago. And Nathan Oakley, by the way, I highly recommend his content as well. Nathan Oakley, like that would be pretty good for him to debate a globe earther. Yeah, he always does, and he always puts them in their place. Anyway, that's where I heard some globetard called Brian's Workplace and tried to have him fired. So this is what I mean, like especially when people give their full names and stuff like that. You have people that are crazy. Okay, they're so misinformed and just blindly following like a pseudoscience without doing their own research or experimentations, none of that stuff. And they're trying to ruin people's lives. So this is how ridiculous. They can't just shut off the TV. They can't just not watch this content. They have to actually go out of their way to try to destroy our lives. And so it's just, and that is true. And that is why he got out of the system. And so, I get it, because people are crazy. And it's just like a religion, right? When people blindly follow the Bible or the Quran or any other friggin' texts or occult belief systems, it's just there's allegories and there's truths, and then there's facts, and there's a difference. And so when people take these texts or these scriptures or these things literally, and then they get this authorization to kill on behalf of that ideology or that opinion that's not based on facts. It's like a free reign. It's like kept authority. And I've shared this in countless behavioral experiments that I've shared also online. When people are given the approval or the permission from someone that looks to be a professional, they will even kill someone that they don't even know for zero credible reason. Not that there's not that should be any reason to kill someone. That's what I'm saying. It's the opposite of what you should do. But we're 2/3 of people in behavioral studies, we're actually going to lethally electrocute people on the other side of a wall during an experiment because of getting really menial, like insignificant questions wrong, like multiple choice questions wrong, and just because a guy that was an actor had zero certifications or qualifications for any type of like expert career or anything like that, an actor right off the streets was like, yeah, keep doing it. And like, okay, I'm just gonna kill this guy now. Like, are you crazy? And then you look at the Stanford prison experiments in Universe 25, and it's just it's unfortunate that like people like Craig are just preventing good discourse and debate, but also like lying to humanity. That's what frustrates me. That's why, like, intellectual bullies like that are that are wrong. Like, it's just they're running the world right now, and it's unfortunate, right? It's just really sick, twisted people that I don't understand why they want to keep this lie going. I don't understand why. It's ruining the world.
How he determined this gravitational constant.
Oh,
Okay.
good.
Cavendish apparently had a lot of property, a lot of money, and
I hope he's happy.
set up an experiment where, get rid of all this. Now let's go back to where we just have these two equations. They haven't figured out the big G yet. They do know the radius of Earth, though, because they knew the circumference. So they knew the radius of Earth, but they didn't know big G, and they didn't know the mass of Earth. Okay, So going back to Cavendish in 1798, Cavendish built this box, this wooden box on his property.
1798, eh?
Something like this.
And did he even exist?
Okay, and in this box, there was a pulley with a rope leading outside the box, something like that, a little handle on it. And what hung from it was this thing called a torsion rod. It's something like this. And on the ends of the rod were these large lead balls. And on the inside were these smaller lead balls, something like this. Pulley right here. And he used lead because it's very massive, it's very dense. And he apparently, according to the history, he knew that he had to get away from the box because his gravity, his mass would affect the experiment. Assuming that this is correct, that the force of gravity is, there's a force of gravity between any two masses, not just the Earth and us. All masses have a force of gravity on each other, or create a force of gravity on all other masses based on this equation and the proportion that Newton came up with. So he somehow set up some telescopes that went back to his house. Keep his house off the board, just assume his house is down here somewhere. So he could observe this experiment, and somehow he calculated big G from this. Okay. Well, when I started researching this, I said, okay, well, let's see some examples of a modern day torsion rod experiment that somebody's built that shows how this works. Well, I couldn't really find one. I actually had a lot of trouble finding one. Actually, one of the physics professors that was praising him had a little model that he held up and was joking that his TA couldn't get it to work and got frustrated with it and gave up. And I'm thinking to myself, over 200 years later, we don't have models of this or repeats of this experiment all over the place that determine big G. It didn't make much sense to me. So I said, okay, well, going back through the history, let's assume that he did this somehow. He's a really smart guy, and we just haven't been able to get it to work again. Okay. So Cavendish determined big G through that torsion rod experiment. Okay. So he calculated it to be the value that we're still using, which is 6.67 408 times 10 to the negative 11 meters cubed over kilograms times seconds squared. Okay. He determined that from that experiment. Let's assume that's correct. So now he must have been really excited because he knows what this big G is. He knows what his mass is, or any other mass of an object on Earth. He knows what the radius of Earth is. So he can set these two equations equal to each other. He knows that weight and the force of gravity are equal. So what he did was, you can look this up. This is exactly how this was done. Weight, which is equal to mass times G, or the mass of the man or whatever object he's using. In my case, I'm going to say me, is equal to big G times the mass of the man times the mass of Earth divided by the radius of Earth squared. Now, immediately, you can cancel the mass of the object, or me, out, because they're in the numerator on both sides. This is really mg over 1. Okay? And now, let's come up here. You can solve for the mass of Earth. You can multiply the radius squared times both sides, and that comes over here. Cancels on this side. And then you can divide by big G. So you get ME, and this is basic algebra here, is equal to little g, the acceleration due to gravity, or the rate at which things accelerate towards Earth, times the radius of Earth squared divided by big G. And that is how the mass of Earth is calculated. That is the mass that NASA has on their fact sheet, where I got all this information about the Earth's radius and the mass of Earth and everything.
Wait for it.
For this problem. Okay. So I looked at this and I said, okay, that makes sense. But I still had the question in my mind saying, wait a second, though, why can't we do this torsion rod experiment now? There's some, I looked into this more, and right now there's debate going on about what this big G actually is. Some people are arguing and saying it's different. And they're doing experiments on an atomic and a subatomic level, where they're looking at particles with very powerful microscopes and observing how they're attracted to each other, which they say is because of gravity. Now, I can't go buy an electron microscope and do those experiments myself to check it, because I don't have that much money. And I don't want to try to build a torsion rod experiment, because from everything I read, it sounds like it's not going to work. So I'm also going to spend a lot of money on that. So I'm really questioning, this big G. How did they come up with that? But then I started to look at this algebraic expression that was written. Get rid of big G again. Say, well, what if they were so sure about this equation due to gravity, or this equation of gravity, that they were having trouble coming up with G, that they did something else to determine it? What if they did this, or Cavendish did this? What if he said G is equal to the acceleration due to gravity, as he would have called it, times the radius of Earth squared, times the mass, or divided by the mass of Earth? Of course, he doesn't have the mass of Earth, right? Well, he does have the radius of Earth. And at that time, they definitely knew how to calculate the volume of a sphere. The volume of a sphere is equal to 4/3 times pi times the radius squared.
Oh, this is old freaking math to me. It's so ancient. I haven't done this in years.
So since they know the total volume of,
this is what I mean. I'm trying to go through these notes again, because I've gone through the science quite a bit, but even with the basic, not basic, but physics and chemistry, I haven't done that since university. And so I gotta re-memorize, like, how do you find volume? How do you find mass? How do you, like, et cetera, et cetera. Well, I mean, not how do you, like, I know how to do it, but just write it down.
The Earth,
because you can't memorize all this stuff.
they
No way.
know that if they could figure out the average density of Earth, they could multiply that by this volume and get mass.
Yeah.
You know, if you know, at the time they would have known the density of water and the density of sand, the density of ground rock, the density of iron, the density of gold, the density of silver, the density of all these things were already determined. And to determine the density of something, it's really just the mass per unit volume. For example, we'll call them rho. Call rho density. Rho water is equal to 1,000 kilograms per meter cubed. What that says is in 1 cubic meter, if you have you have something that holds a cubic meter of water, it weighs 1,000 kilograms. If you have something that holds 2 cubic meters of water, you say the density of water 1,000 kilograms times 2 cubic meters. You see the cubic meters would cancel. You get 2,000 kilograms is how much it would weigh. Okay, so you definitely know the density of water back then. You definitely know the density of, let's say sand and soils, which is roughly 1,200 to 1,600 kilograms per meter cubed. And they definitely knew the density of iron. I mean, they were building things out of iron a long time before that. We'll call that rho I. And that is equal to 7,780 kilograms per meter cubed. Now, whether they were using metric units again, I don't know, but they would have had their units that could be converted to the units I'm using now, or the metric units I'm using now. Now, based on the volume of Earth, let's call that VE, the volume of Earth is actually 1.083 times 10 to the 21 meters cubed, okay? If you use NASA's fact sheet with their mass of Earth, which is 5.9726 times 10 to the 24th kilograms, and you divide that by the volume of Earth, you will get an average density of Earth, I'm going to call that rho E over here, of 5,515 kilograms per meter cubed. Okay? So, looking at this, just looking at water and soil, water is, the average density of Earth is over 5 times greater than the density of water. And water is actually pretty dense. If you've ever done a belly flop into a pool, you've seen you've experienced how dense it is. But, the average density of Earth is 5 times that of water. It's also a lot greater than soil and sand, which is really ground rock. But then you look at the density of iron and notice that actually the density of Earth is pretty close to the density of iron based on everything that was calculated, the mass that came from this relationship here. So I started thinking, this is pretty high. And that's exactly why we theorize that the Earth has an iron core, because this is the average density of all the stuff in Earth, all of the elements, everything on the periodic table that we know. Now, at the time, they didn't know all the elements on the periodic table, but they knew a lot of things. So what I'm saying here is, if you follow where I'm going with this, how do we know?
He's getting to good points, but I just wanted to show that you can't eliminate electrostatics from the experiment, not even in a vacuum, and it's 10 to the 26 times stronger than gravity is. Even claimed to be. Like, I love this point as well, right? Because even like with Craig, I'm going to show if there's time. Like even with Dave Weiss, with the videos he's done with like electrostatics with the balloon test that he does, where it's connected to like a wire, and like when he manipulates the electricity, like that's what makes the like the balloon like raise and lower. This has nothing to do with gravity and everything to do with manipulating the environment. Anyway, it's so great point as well. I think that like with Toon or whatever and Craig, like I think that they're paid they're either paid to disrupt the community of truthers, and the fact that they're doing that like is kind of like pathetic and sad, and like do something else with your lives, right? Like, and you can also make a lot of money, possibly like being a flat earther, right? Like if you do it properly, and but I mean the fact that like this Toon girl or whatever like that, they're going to these events, like with Greg Locke and Dean Oldley, and just trying to be a disruptor. Like it's just like those like people that are part of like extremist groups like BLM and Black Lives, that is Black Lives Matter, like BLM, Antifa, like even like extremists on all sides. And so are they just extremists? And if they are, that's also a reason why like you're not able to, like we're not able to get through to extremists. Like who gets it through to extremists, right? And so are they extremists or are they controlled opposition? Because they're definitely not looking at any of the data that we're putting out there. And I'm saying even the data that like when you like, he's also not getting that there's that there are equations like I just shared on ChatGPT, where the same calculations would be derived using different algorithms, and because it means the same thing. This is so hard to freaking explain because again, this is all stuff that's like, you know, it's like the most complicated stuff you can talk about. But fuck, I forget where I was going with this tangent. Anyway, I'll just keep this conversation going because like he's brilliant, and I like the points he makes at the end too.
They didn't guess.
Oh yeah, so like whether it be a globe or a sphere or a circle or whatever, the same like trigonometry, the same mathematics, the same results will be derived.
Just didn't guess this mass of Earth, and then just use it to solve for G, and then do the opposite and say that he did this. If he solved for the mass of Earth using that value of G, it's the same thing, just based on the algebra. And then if you plug both of those values into this equation up here and use the mass of any object, whether it's a man, a horse, you know, a carrot, anything, and use the radius of Earth, you're going to get a force that's equal to the weight you get for that same object if you just multiply the mass of that object's time and acceleration due to gravity, or the rate at which acceleration at which things fall towards Earth.
I like the rate at which things fall to Earth.
Seem far-fetched? I don't know. You know, the fact that we can't,
and that's just
really
based on the fact that that's just based on like this container, like this cosmos is what I'm talking about, where it just so happens that when things are less dense than the atmosphere, the environment that it's occupying, and there's other factors as well, like pressure systems and temperature. I'm not fucking saying it's not. Again, like I'm just saying, like we're using this model as the fucking example here, and so even with gases being lighter than like the standard oxygen air composition that we have, like that's why like helium balloons and stuff like that raise, because it's lighter than the environment that it's occupying, and things that are more dense, again, it lowers or sinks to it's hard. Like you can call it so many different terms or so many different words, right? To the to like the until it gets to a point of resistance or friction, where it's in an environment where it's less dense than the environment that it's occupying.
Torsion rod experiment to work is perplexing, very perplexing.
And this isn't even my so it's again, this isn't even my expertise, right? Like I could, like for me, it's the astronomical mathematics regarding like the luminary travel paths and the connections with the various representations of the sun and its path through the zodiacal belts, like throughout like multiple different advanced civilizations and like throughout the world. People like Mithras and Dionysus and Apollo and Helios and Jesus and countless others. Vishnu. So Shiva and Vishnu in Hindu religions too, the sun and moon representations as well. But I keep going. Sorry about that. It's already a long video.
We have to trust that they didn't do this. But what if they did? Our entire solar system model stems from this, assuming that this is correct, assuming that this big G, this gravitational constant, is correct. So
yeah, I'm just gonna put this up as well, November Bear, because like it also depends on the atmosphere, the humidity, like the temperature. There's so many other factors as well, like that also change, and so I do like that as well. There'd be like settled. I could see that.
I don't know.
Oh, like the Earth curve calculator. I'll talk to Craig about that, because like that to me is more significant and important even than all the other stuff, right? Because like gravity, like this theory, like we're talking about gravity, just a fucking theory now. And again, you've got electricity, you've got magnetism, we've got like forces. Well, you've got a unified force or cosmos that's experiencing itself dualistically via electricity and magnetism, where you have like a centripetal versus centrifugal, integrating versus disintegrating, heating versus cooling, magnetic versus electrical, radiating versus gravitational forces or energies. Like, and this is so the fact that like, anyway, such a small part of like the fucking reality of the world. Like, it just bothers me that this guy's always fucking talking about this.
What the thing?
Move on. You're wrong. Move on.
But
Something else.
one thing I do know, based on my research, another thing I found out based on my research, is that Cavendish and Newton were both Freemasons. It's a very big club.
And so is Copernicus.
And back then,
and that's even if he existed.
the average person couldn't even write their own name. So people slowly were introduced to the sciences. More and more people were introduced to the sciences over the years, and it wasn't just the wealthy people. And I know there's a symbol out there that a lot of people have been trying to figure out. It looks something like this.
You got phi, pi, alpha, omega. Anyways, with a phi. And then you G, the free friggin' Mason like symbol logo. I talked about that as well
You've seen one of these before? Found them on a Freemason lodge. It's kind of ominous symbol. First time I saw it, I was like, "What was that?"
The envelope too that they have on the friggin' the
Gmail.
Gmail.
Protractor. The big G in the center, but what does that stand for? I don't know. Could just be a coincidence. Some people think it means geometry. Some people think it means God. I don't know. Some people even think it means Gnosticism. I've done a little research on this. Who knows?
Thinks it means Jesus. Or it could be gravity.
It's just a coincidence. I'm just asking questions. But
the center of the Freemason.
In the next episode, we'll look at the relationship between this equation and centripetal force equation and how it was used to develop our solar system. Till next time, peace.
So brilliant. And he has so many other great videos just like that. And so, of course, I am going to, whenever this debate gets lined up, of course, I'm going to do a bunch of notes and get through that stuff, because I know he's going to try to make me look stupid on that stuff. And it's fine. I'm comfortable. Like, again, I'm not going to say anything that I don't know, and I'm not going to try to explain things that I don't know. And that doesn't mean that the earth is not flat. If I can't explain some kind of like a fucking like unicorn random like a theory, again, that has nothing to do with the actual reality of the world, that is just another friggin' way to distract people from the actual science, right? There's a lot of people that try to deviate away from the actual facts with these other friggin' things that they talk about, and it's just more like, what do you want to call it? Like unicorn dust. It's more like rainbows and whatever you want to call it. It has nothing to do with anything else. So I'll talk about, levels, because he doesn't know about levels too much about that, and about radar, and because there's even talk about radio waves, right? Radio wave echoes that have hit the sun, which proves that the sun is a physical law. All this bullshit, again, that can be easily debunked. Like, even with like the fact that like look at radio, look at low frequency waves and how far they can travel. Look at high frequency waves and how far they can travel. Look at what they can travel through for like radar as well. Radar, look to see if it can work on moving versus non-moving objects. Again, like, I'm not even gonna like give all of my cards away, but I want to see if like he actually knows this stuff, right? And if he knows what radar travels through or can pass through. Okay, and so like, let's see, could it possibly travel through an electromagnetic field? I don't know. You tell me. Can it travel 93 million miles away? right? Let's look at this stuff, Craig. I'm not saying Craig, I don't know why. I'm going to stop talking about him, like, obviously on my next videos. Just today is just, I've been back and forth even after my earlier video, just like I'm being a troll too. I'm not going to lie. Like, well, not being a troll. Like I'm hitting back. Usually flat earthers, they'll just ignore the trolls because like they're being very negative on Jeranism's video that I shared this morning. There's a lot of like negative comments, and there's not a lot of negative comments, but overall there's a lot of great comments, and people are overall very impressed with Dave, and absolutely know that he won that debate. But I'm saying like that Craig has commented on pretty much every single friggin' comment to troll people that are saying it was a good video even. And so I'm hitting back, and then he's getting like one or two people that are also like repeatedly commenting on people's comments that liked the video and liked Dave better. And so like this is what I mean, like they have no jobs, like that's their full-time job. So that's why they're getting paid by some kind of a controlled opposition. But anyway, so like Eric's book, like I referenced his book. I gave I cited that, I copied and pasted in, said it's from friggin' Eric. Take no credit for that. And then I also shared a video that debunks even the Coriolis effect, which was also brought up. And so are they gonna like take a look at this stuff? Probably not. And yeah, so, but even that Coriolis effect debunking video, I can say that for other videos, because I will leave at that on that note. And I hope that everyone has a wonderful rest of your day.